In 1930, this guy named Clyde Tombaugh, who was working in Arizona, it was the observatory in Flagstaff, Arizona. He was looking at some photographs um, of objects an object that he realized was part of our solar system. So basically, what he if you look at this slide A right here, um, I mean, this is the kind of thing that he noticed is that um, you know the planet. Well, at the time, it became known as a planet. Of course, nowadays we consider it a dwarf planet or a minor planet, and we'll get into why that is a little bit. But anyhow, he sees this point of light, and and of course, it looks like a star, right? And that's through a telescope. That's kind of what Pluto looks like. You have to have a pretty powerful telescope, um, not like a typical backyard telescope to actually be able to see Pluto. Um, these are generally professional telescopes that are put on top of mountains. Anyhow, he sees this dot, this little speck of light, but the thing that tells him that it's part of the solar system is that it moves, right? It moves, over the course of about a week or 2 weeks or so, and he was able to work out the orbit of using the modified version of Kepler. Well, sorry, Kepler's third law actually, by figuring out the period. Um, anyhow, it's actually not that complicated if you know how much the object is moved in the sky, and approximately the arc length of the of the picture that you're looking at. In other words, it's the object's moved from here to here. What is that? Um, what is that angle? And so once you know that, and of course you realize that to go around the sun, it would take 360 degrees. Um, then you can figure out what the period is, and once you know the period, you can figure out the semi major axis. Remember Kepler's third law: a cubed. A is the semi major axis equals p squared, where p is the period of anything orbiting the sun, or something that has the same mass as our sun, uh, in years. All right, so that's how Tombaugh did this, um, and almost right away, from 1930, um, you know, Pluto was considered a planet. Um, it wasn't until the 1970s, if I remember correctly, that its largest moon, Charon, and by the way, you can pronounce that Charon or Charon. If you haven't had the last lab yet, Lab 13, um, there's a lab that deals with the size of Charon and the size of Pluto by using the fact that Charon, we can see Charon pass behind Pluto and then come out the other side. And if you time that, and you can figure out approximately the diameter of Charon, and also the diameter of Pluto, right? Just by timing that information and knowing how fast Charon moves around Pluto. All right, so anyhow, the story, for a long time, you probably already know that Pluto was considered the ninth planet, and some events happened in the year, I think it was 2003 or 2004, right? And so, here, uh, let me look at the next slide here. Well, we'll get to that in just a minute. All right, so I'll bring us up to date. All right, so like I said, for almost 70 years or so, this was considered a planet, and kids learned that it was a planet, and everything. Uh, Nowadays, it's considered, and anything that is beyond the orbit of Neptune is, so sometimes they give it the designation TNO, a trans-Neptunian object. Um, and they're also, Pluto is one of these. It's actually turns out to be the largest one. It's also a member of this region of the solar system called the Kuiper Belt. All right, so it's really important there it is. There in the 1970s was the discovery of Charon. I didn't even read uh, my own little thing. And then Pluto is reclassified. Instead of being a full on planet, it's reclassified as a minor planet, or sometimes called a dwarf planet. And that was in the year 2006, because in 2003, I think it was 2003 or 2004, there was a discovery, um, and that discovery was that there was an object out beyond the orbit of Pluto. And at first measurement, when we used our first values of this object, which it later turned out to be uh, an also a minor planet called Eris. At any rate, the first measurements of Eris back in 2004 showed that it was slightly bigger than Pluto, and it had its own moon. Right, and so the guy that discovered it, Mac Brown, went home. He told his wife, "Hey, I found the 10th planet." Because at that time Pluto was still considered the ninth planet, and so it turns out that you know um, the the astronomical community decided to get together, and in 2006 they had several votes. I mean, it was quite contentious at times, but finally they voted that there were these three criteria that make something a planet. All right, so let me go over those real quick. Um, First one is it has to be large enough to self-gravitate into a sphere. Certainly Pluto does that. I mean, heck, even the moons, a lot of the moons in the solar system do that. All right, so that's one of the criteria. The next criteria is that it has to orbit the sun. All right, so in that sense, the moons go around their own planet. The planet goes around the sun. All right. So now you're down to 9 or 10 planets. The third criteria is the thing that took Pluto away from planethood, for being considered a planet. And so what the third one says is, if it's truly a planet, at the distance it is from the sun, all material, or most of the material, should be cleared out. In other words, it's such a massive object that anything that is in the same orbit as that object, as if it's a planet, will be gravitationally attracted to it over time, right? Now, see, Pluto does not meet that last criteria, because there's stuff that is about the same distance in the Kuiper Belt. Eris is actually a little bit further out in the Kuiper Belt, but there's all of these trans-Neptunian objects. Actually, we know about. We've seen hundreds and hundreds and hundreds of these things, and that's actually a region of the solar system that is currently being investigated. Right, so and now in 2015, we actually NASA had launched 10 years earlier, had launched the New Horizons spacecraft, and that's how we got these close-up pictures of of Pluto and Charon. All right. So anyhow, all right. So now Pluto was always an oddball. Just to one of the strangest things about it, right off the bat, right after it was discovered and its orbit was worked out, mathematically, it turns out that Pluto will actually and does actually cross the orbit of Neptune, so that there are times it's like I forget, it's about a 20 to 30 year period where Pluto is actually closer to the sun than Neptune is. See, the planets for the most part are they're all elliptical orbits, but they're only slightly elliptical. Pluto's is very eccentric, right? So it's extremely eccentric. Um, and the other thing about it is, this slide down here is showing this better, is that Pluto, it does not follow the plane of the solar system. It's tilted greatly with respect to the plane of the solar system. I think, if I remember correctly, it's like, I'd have to look it up. I remember a number, something like 16 degrees or something like that. I would have to look that up exactly. But anyhow, it's tilted with, remember, all the planets are more or less in the same plane. That's why, the sun follows this thing called the ecliptic. All the planets are roughly around the ecliptic. So that's why you always find the planets in the constellations of the zodiac, right? That because that's what they follow, the ecliptic. Pluto does not, right? So you find Pluto in other constellations, just outside of the constellations of the zodiac. All right. So Pluto and Charon are they are actually it's the largest moon, not the largest moon in the solar system certainly, but it's the largest moon compared to its host, the host body, right? I mean, Pluto's not a planet, considered a planet. It's a minor planet, but and actually Pluto has some other moons, really really tiny moons. One of them is called Nix, and what's the rest of them named? They're little tiny things. They're like the size of asteroids. Whereas Charon is pretty large compared to the size of Pluto. All right, so let's see. Charon sounds implies it's highly tilted as well. Oh yeah. So Pluto's orbit is so how the Earth is tilted 23.5 degrees. Pluto is actually tilted greatly, as well, and Charon follows the equator of Pluto. It takes 6.4 days for Charon to go all the way around Pluto once. So the eclipses have given us the radii. Pluto's diameter is about 1/5 the diameter of Earth. Charon is about half the size of Pluto, and but it's only about 12% as massive as Pluto. Pluto's density turns out to be a little higher than we expected. More, so it's actually higher than the than the gas giants, right? So it's about 2.1, which suggests it's not only made of ice. There's some rocky material in there as well. All right. This is the New Horizons spacecraft that made it was only a flyby in the year 2015, but that's given us the most detailed information about Pluto. Because even with really large telescopes, even with the Hubble Space Telescope, you never got, as clear an image of Pluto as this, and certainly as clear an image of Charon.